Hello everyone. So today's topic is straight lines. Straight lines. So what is a straight line? A line with a constant slope and which can have maximum of two intercepts is known as a straight line. A line with a constant slope and which can have maximum of two intercepts. So it is known as straight line. It is known as a straight line. So there are many intercepts of a straight line. First is horizontal intercept. In this, a straight line will intersect y-axis at one point, and we call this point as y-intercept. So this is y-intercept. That is called point B 0, a. Second is vertical intercept. That is, if a line intersect x-axis at one point, then we call it vertical intercept, and it is known as x-intercept. Third is if line intersect at 2 points. This line is called as inclined line, and it has two intercepts. So it has x-intercept as well as y-intercept. So there are three types of lines with which we can get three types of intercepts, and maximum of two intercepts we can get from a straight line. That is horizontal intercept, vertical intercept, or a straight line with two intercepts. So this was about a straight line. Now how to plot a point on a Cartesian system. How to plot a point on a Cartesian system. So let's say we have a point 3 comma minus 2 as a point where x is 3 and y is minus 2. So that is x is 3 units along positive x-axis, 3 units along positive x-axis, and 2 units along negative y-axis. Therefore point will look like so this is y-axis, this is positive y, and this is negative y, and this is x-axis, this is positive x, and this is negative x. So 3 units along positive x-axis. So we have this point 3, and 2 units along negative y-axis. So this is, so point will be, so this is the required point 3 comma minus 2. Here we first go towards right 3 units, and then we go 2 units towards negative y-axis. Next is how to find a distance between 2 points x1 y1 and x2 y2. How to find distance between 2 points x1 y1 and x2 y2. So let us create the line on a Cartesian system. This is x-axis, this is y-axis. Let the line be L, and we have 2 points P comma Q, where Q is x2 comma y2 and P is x1 comma y1. So by distance formula, distance formula, the distance is given by root of x1 minus x2 whole square plus y1 minus y2 whole square. So this is a distance formula. Whenever we have 2 points given, we can use this formula to find a distance between 2 points, and distance is always positive. So what is a section formula? So find the coordinates of a point that divides the segment in the ratio m ratio n. So what are the coordinates of a point that divides the line segment in the ratio m ratio n. So suppose we have a line and we have 2 points x1 y1 and x2 y2, and there is a point, suppose x comma y, which divides the line AB in the ratio m ratio n. So we can write as the point x will be m comma m into x2 plus n into x1 divided by m plus n. Similarly, we can find the point for y, that is m y2 plus n y1 divided by m plus n. So this is known as section formula. So whenever we have 2 points and the ratio is given, then we can find the point which divides the line in the ratio m ratio n. Second is, what is the midpoint of the line segment? What is the midpoint of the line segment x1 y1 and x2 y2. So if we take the same line and same points a and b, and this is x1 y1 and x2 y2, and there is a point x comma y which divides the line segment into m ratio n. So if point, let this point be p, if p is a midpoint, then we can say m is equal to n. So by section formula, we have point P x coordinate as m x1 plus n x2 divided by m plus n. So because m is equal to n, therefore x is equal to x1 plus x2 by 2. Similarly, for y, we get y1 plus y2 divided by 2. So this is the required midpoint of the line segment. This is the midpoint of the line whenever m is equal to n. Next is what is the area of triangle whose vertices are x1 y1 x2 y2 x3 y3. What is the area of a triangle? What is the area of a triangle whose vertices are x1 y1 x2 y2 and x3 comma y3? So if we have so we can write the area as, area is given by, this is a standard formula, so we can write as x1 y1 1 x2 y2 1 and x3 y3 1. Or we can say area is equal to half x1 into y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. That is, if x1 y1 is a point, x2 y2 is a point, x3 y3 is a point, then we take x1 and bracket multiply with the difference of y2 and y3, y2 minus y3. Again we take x2 and we take next point y3 and then y1, so y3 minus y1. And next x3 is, if we take x3, then we will take next point of y1 of y1 and y2, so y1 minus y2, and we add all these terms. So the area is given by half of x1 y1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, and this is a modular sign which represent the area is always positive. Area is always positive. Next is collinear triangle. If the area of triangle ABC is 0, if the area of triangle ABC is 0, then 3 points A, B and C, then 3 points A, B, C lie on a line, that is, they are collinear. Next is, what is the inclination of a line? So if we have a line, this is a Cartesian system, and we say that this is any line L, and it is making angle theta in the anti-clockwise direction with x-axis. So the angle theta made by the line L with positive x-axis and measured anti-clockwise. And is called inclination of a line. Where theta lies between 0 and 180 degree. Where theta is between 0 and 180 degree. So when the line is parallel, or coinciding with x-axis, then we have theta is equal to 0, and when the line is perpendicular to x-axis, then theta is 90 degree. That is, when line is parallel to x-axis, then theta is 0 degree, and when line is perpendicular to x-axis, then theta is 90 degree. Next is, what is a slope? What is slope? So if theta is the inclination of a line L, then tan theta is known as slope or gradient of a line L. If theta is the inclination of a line L, then tan theta is known as slope or gradient of a line L. So if we define the slope of a vertical line, that is, we can also represent slope as m, which is equal to tan theta. So slope is equal to tan theta, where m is a slope and theta is the inclination angle. So if we define the slope of a vertical line, then slope of vertical line, then theta is 90 degree. Theta is 90 degree. So slope is not defined. Therefore slope is not defined because tan 90 is infinite. Second, a slope of a horizontal line. Horizontal line when theta is 0 degree. So slope is equal to 0 because tan 0 have a 0 value. Next is slope of any line when coordinates of any 2 points on the line are given. Slope of a line when coordinates of any 2 points on the line are given. So if we have a Cartesian system and there is a line and we have 2 points P and Q, those coordinates are x1, y1 and x2, y2. So if we construct a triangle, so this is a Cartesian system. This is point P and this is Q. We construct a triangle PQM where theta is the inclination angle. So angle P will also be angle theta and coordinates of P are x1, comma y1 and coordinates of Q are x2, comma y2 and coordinates of point M will be x2, comma y1. So by distance, so we can find the distance of QM and PM by distance formula. So QM is given by root of x2 minus x2 whole square plus x2 minus y1 y2 minus y1 whole square. So therefore QM is equal to y2 minus y1. Similarly PM is equal to, we have x2 minus x1, and by definition of a slope tan theta is equal to perpendicular distance upon base from the trigonometric identity. So from triangle PQM, perpendicular is equal to PM and base is equal to QM. So perpendicular is QM and base is PM. So QM we have y2 minus y1 and base is x2 minus x1. So slope is given by m is equal to tan theta is equal to qm by pm equal to x2 minus y2 minus y1 divided by x2 minus x1. So therefore slope of a line whose coordinates of any 2 points are given is given by y2 minus y1 divided by x2 minus x1, where slope can be positive or negative depending on the value of the inclination angle. That is, if inclination angle is acute angle, then slope is positive, and if the inclination angle is obtuse, then slope is negative. So what is the relationship between the slope of two parallel lines? Relationship between slope of two parallel lines. So if you have a Cartesian system and this is y-axis, this is x-axis, and we have two lines L1 and L2, where L1 is at angle alpha and L2 is at angle beta. So if two lines are parallel, then their slopes are equal. If two lines are parallel, then their slopes are equal. Since their inclination angles are equal, therefore we can say alpha is equal to beta. So we can take tan on both sides, taking tan both sides. So we have tan alpha is equal to tan beta, and tan of any angle is given by slope. So this is the slope of line L1, slope of line L1, and this is slope of line L2, or we can call slope of line as M1 and slope of line L2 as M2. So from this we can say M1 is equal to M2. Whenever the inclination angles of two lines are equal, then their slopes are equal. Next is relation between the slope of lines when two lines are perpendicular. Relation between slope when two lines are perpendicular. When two lines are perpendicular, that is, this is a Cartesian system, and this is line L1 and this is line L2. So this is angle 90°. So inclination angle of line 1 is alpha, and inclination angle of line L2 is beta. So if we take this enclosed region as triangle ABC, A, B and C. So it will look like this: A, B, C, A, B and C. So angle B is alpha and angle C will be 180 minus beta, and angle A is 90 degree. So from the property of triangle, sum of all angles is 90 degree. So alpha plus 90 plus 180 minus beta is equal to 180 degree. So we get beta is equal to alpha plus 90 degree. So taking tan on both sides, taking tan on both sides, so tan beta is equal to tan alpha plus 90 degree. So tan alpha plus 90 is minus cot alpha and tan beta. So from this, tan beta is the slope of line L2, and cot alpha can be written as 1 by tan alpha, where tan alpha is slope of line L1. So we can write it as slope of line L1, L2 as M2, and slope of line L1 as M1. So from this, M2 is equal to minus of M1, or M1 M2 equal to minus 1. So this is a relation when two lines are perpendicular. Next is angle between two lines. Angle between two lines. So consider a Cartesian system where we have two lines. So this is line L1 and this is L2. L1 has an inclination angle of alpha and L2 has an inclination angle of beta, and this is the angle between two lines, theta. So if we consider point A, intersection point, then we can see a line L1 and line L2, and if we create a reference line, so L1 is at angle alpha and L2 is at angle beta. So theta is equal to beta minus alpha. From the algebra of geometry, we can find this angle as theta. So taking tan on both sides, taking tan on both sides, so tan theta is equal to tan beta minus alpha, and from the identity of trigonometric identity, tan x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. So tan theta is equal to tan beta minus tan alpha divided by 1 plus tan alpha tan beta, where tan alpha is the slope of line L1 is equal to M1, and tan beta is slope of line L2, which is equal to M2. So the tan theta can be written as M2 minus M1 divided by 1 plus M1 M2, where theta can be negative, theta can be where tan theta can be negative or positive depending on the inclination angle theta. Depending on the angle theta, if theta is acute, and tan theta is positive. If theta is obtuse, then tan theta is less than 0, and 1 plus m1 m2 is not equal to 0. So we can also write tan theta as plus minus m1 minus m2 1 plus m1 m2, or we can put a modulus sign. Tan theta is equal to mod of m1 minus m2 1 plus m1 m2, where 1 plus m1 m2 is not equal to 0. Next is collinearity of 3 points. Collinearity of 3 points. So we have already learned collinear. Whenever 3 points are collinear, they lie on a straight line. So if we have 3 points A, B, C, A, B and C, they will lie on a straight line. They will lie on a straight line. Then we can say that slope of AB is equal to slope of BC. So geometrically we can see like this. This is a line and these are 3 points A, B and C. So slope of AB is equal to slope of BC. So whenever slope of two lines are equal, and then the points lie on a straight line, so the points can be collinear. Therefore the points ABC are collinear. Next is equation of a line. Equation of line. So first is horizontal line. Horizontal line. So consider a Cartesian system. At some point A, there is a horizontal line. So we can call this as y equal to A. So the equation of horizontal line is y equal to A. Or we can consider another line which is at negative y-axis, which is y equal to minus A. So another equation of horizontal line is minus A. So this is the equation of horizontal line, y is equal to plus minus A. Next is vertical line. Vertical line. So vertical line will, whenever a line intersect x-axis, suppose this is point A, so we can call this equation of line x at x equal to A or x equal to minus A. So the equation of vertical line is given by x is equal to plus minus A. Next is point slope form. Point slope form. So this is a Cartesian system, and this is a line where slope is m, slope equal to m, and we have 2 points x comma y and x naught y naught. So from the definition of a slope, slope is equal to y minus y naught divided by x minus x naught. So we can write in the form of y is equal to m x minus x naught plus y naught. So this is the point slope form where we have 2 points and the slope is given. So we can find the equation of a line as m x minus x naught plus y naught. Next is 2-point form. 2-point form, we are given 2 points on the line x1 and x1 y1 and x2 y2, and we have to find the equation of line. So from the condition of collinearity, consider a point, any point P whose coordinates are x comma y, so which lie on a same line. Suppose this is a vertical line and this is x comma y1 and this is x2 y2, and there is a point, a random point x comma y1, x comma y. So the slope of AB is equal to slope of AP is equal to slope of BP. So slope of AB is equal to y1 minus y2 divided by x1 minus x2, and the slope of AP is y1 minus y1 minus y divided by x1 minus x1 minus x is equal to slope of BP, which is y minus y2 divided by x minus x2. So this is we can call it m, and we can take any form. So suppose y1 minus y divided by x1 minus x is equal to m, or y minus y1 divided by x minus x1 is equal to m. So y minus y1 is equal to m x minus x1. So y is equal to mx minus x1 plus y1. So this is a equation, and if we take this third form, then this will be, then y is equal to m x minus x2 plus y2, which is equation B. But both these equations are same. We can use any of the form, any of the equation. So this is the 2-point form where 2 points are given and we take a third point x comma y, and we find the slope of between 2 points and then find the equation of a line. Next is slope intercept form. Slope intercept form. In this we are given slope and intercept is known. Intercept. So we have discussed the intercept, three types of intercept, x-intercept and y-intercept. So whenever the line intersect x-axis, we get x-intercept, and when the line intersect y-axis, we get y-intercept. So consider a line on Cartesian system which has y-intercept 0 comma c and which has slope of m, and consider any point x comma y on the line. So slope is given by y minus c divided by x. So y is equal to mx plus c. So this is a slope intercept form. We can also write in the form of x intercept. So if we write this, if we plot the x intercept at t comma 0 and consider any point x comma y, then the slope is given by y minus 0 divided by x minus d. So where y is equal to m x minus d. So these are two types of slope intercept form. This is when y intercept is given. So when y intercept is given, then we have y is equal to mx plus c, where c is y intercept. And when x intercept is given, then y is equal to mx minus d, where d is x intercept. Next is intercept form. Intercept form. So whenever we are given both the intercept x intercept and y intercept, that is this is a line and this is y intercept 0 comma c, and this is x intercept d comma 0, and consider any point x comma y on a line. So slope of a line is given by 0 minus c divided by d minus 0, which is equal to y minus c divided by x minus 0 is equal to 0 minus y divided by d minus x. So m is equal to minus c by d is equal to y minus c divided by x, or equal to y divided by x minus d. So we can take any of the form and equate with the slope c by d. So y minus c divided by x is equal to minus c by d. So y minus c is equal to minus cx divided by d. Y plus cx by d is equal to c. So y by c plus x by d is equal to 1. So this is an intercept form where c is y intercept and d is x intercept. So if we equate the slope with the second form y upon x minus d, we get the same equation y by c plus x by d, where c is a y intercept and d is a x intercept. Next is normal form. So what is normal form? So whenever we have a non-vertical line, then if we are given a length of the perpendicular from origin to the line, length of the perpendicular from origin to the line, from origin to the line, and second, the angle with normal makes with the positive x direction, the angle which normal makes with the positive direction of x-axis. So if we are given two conditions, length of the perpendicular from the origin to the line and angle which normal makes with the positive direction of x-axis, then we can find the normal form of the equation. So this is the Cartesian system, and this is a line L, and we are given, this is origin, we are given distance P, perpendicular distance from the line, let this point be A, and the angle is alpha. So if we are given P and alpha, then we can find the normal form of the equation. So slope of, so first is slope of OA is equal to tan alpha, which is equal to m1. So because line L is perpendicular to OA, because line L is perpendicular to OA, then slope of line will be m2. Slope of a line L2, line L is will be m2, and from the condition of two slopes, two perpendicular lines, m1 m2 is equal to -1, so m2 will be minus m1 by m1, or m2 is equal to -1 by tan alpha. Therefore we have a point A. So now this is a slope of line L. So now consider point A, consider point A whose coordinates are P cos alpha and P sin alpha. So now we have a point and a slope of a line L, and consider any point x comma y on line L. So a line has, this is a line, this is point A, and its coordinates are P cos alpha and P sin alpha. And if we have any point x comma y and slope is given by m2 is equal to -1 by tan alpha, so by 2-point form we can find the equation of a line. So slope is given by m2 is given by y minus P sin alpha divided by x minus P cos alpha is equal to -1 by tan alpha. So if we rearrange the terms, we get y sin alpha plus x cos alpha is equal to P. So this is a normal form. Whenever two conditions are given, whenever we have a P, perpendicular distance from the origin, and the inclination angle of the normal from the x-axis, then we can find the normal form of the equation. This is a normal form. Next is general equation of a line. So general equation is known as ax plus by plus c equal to 0, or we can say this equation as general linear equation. General linear equation, this equation will always be a straight line, or general equation of line. So first is slope intercept form of general equation of line. Slope intercept form. So if we rearrange the terms of ax plus by plus c, so what is slope intercept form? Y is equal to mx plus c. So if we write ax plus by plus c in the terms of y, we get y is equal to minus a by b x plus minus of c by b. So if we compare with y equal to mx plus c, so we get slope as minus a by b and y-intercept as minus c by b. So this is y-intercept and this is slope, and this is not equal to this c, not equal to this. So next is intercept form. Intercept form. So intercept form is given by x by x intercept plus y by y intercept is equal to 1. So if we have ax plus by plus c is equal to 0, then after rearranging the terms we get x by minus c by a plus y by c by b is equal to 1. So this is x intercept and this is y intercept. So this is x intercept and this is y intercept, and this is of the form intercept form, that is geometrically x intercept is minus c by a comma 0, and y intercept is c by b 0 comma c by b. Next is normal form. We know normal form is given by cos x cos alpha plus y sin alpha is equal to p. So if we consider a line ax plus by plus c equal to 0, and from the condition of two parallel lines such as a1 x1 plus b1 y1 plus c1 equal to 0 and a2 x2 x1 plus b2 y1 plus c2 is equal to 0. If two lines are parallel, then a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So from the above equation, x so from the above equation, ax plus by plus c equal to 0, and x cos alpha plus y sin alpha minus p equal to 0. From the above condition, we can get a by cos alpha is equal to b by sin alpha is equal to c by minus p. So we can write cos alpha as minus ap by c and sin alpha as minus bp by c. So this is first equation, this is second equation. uh, so using trigonometric identity, sin square x plus cos square x equal to 1. So sin square alpha is minus bp by c whole square plus minus AP by C whole square is equal to 1. So we get P square by C is equal to B square plus A square equal to 1. Therefore we get P equal to C by root of A square plus B square, or P equal to plus minus C by root of A square plus B square. So this is P. So now substitute the value of P in cos alpha. So cos alpha we know as minus AP by C minus AP by C is equal to minus of A by minus plus minus of root of A square plus B square, and sin alpha is equal to minus BP by C, which is equal to plus minus B by root of A square plus B square. So this is point P and cos alpha in terms of A and B and C. So if we know cos alpha and sin alpha and P, we can write AX plus BY plus C in the normal form. So we have P is equal to plus minus C by root of A square plus B square, root of A square plus B square, and cos alpha is equal to plus minus A by root of A square plus B square, and sin alpha is equal to plus minus B by root of A square plus B square. So whenever we have P and alpha, then we can write AX plus BY plus C equal to 0 in normal form. Next is distance of a point from a line. Distance distance of a point from a line. Suppose we have a Cartesian system, and this is x-axis, this is y-axis, this is point R, this is point R, and this is point Q, and this is point P. This is any point P, x comma y, and we have a perpendicular distance d from line RQ. So R is a y-intercept, which is equal to minus C by B, and Q is a x-intercept equal to minus C by A. So x-intercept is minus C by A, y-intercept is minus B by A. From equation AX plus BY plus C equal to 0. So from here we have to find distance D. So first is area of triangle. Area of triangle is given by half into base into height. So base is RQ and height is D. So we are given 3 points of a triangle, 3 points of a triangle PQR, that is x1 y1 and 0 comma minus c by b and minus c by a comma 0. So first we find the area of a triangle. So we have 3 points x1 0 and minus c by a, and we have y1 y2 y3 y1 y2 y3. So for x1 we take y2 and y3, and for x2 equal to 0 we take y3 and y1, and for x3 we take y1 and y2, that is difference of y2 and y3, and for x2 difference of y3 and y1, and for x3 difference of y1 and y2. So area of triangle is half uh, modulus x1 difference of y2 minus y3 plus x2 difference of y3 minus y1 plus x3 difference of y1 minus y2. So now we have put the values of x1 x1 x2 x3 and y1 y2 y3. So x1 is x and y2 is y2 is minus c by b minus y3 is 0, y3 is 0 plus x2 is 0, then y3 minus y1 plus x3 is minus c by a and y1 is y and y3 is 0, 0 minus y. So we get the area as half cross minus cx by b plus cy by a. So this is the area of a triangle, and we have written as area of triangle as half into base QR into distance. So we now calculate the distance QR by distance formula, QR by distance formula. So QR is given by root of square by c by a square, which is equal to c square by b square plus c square by a square, which is equal to c by root of a square plus b square. So now we have a distance QR and area of a triangle as half area of triangle as half minus cx by b plus cy by a. So area of triangle is given by half QR into perpendicular distance t. So half Cx by b plus Cy by a is equal to half cross c by root of a square plus b square into d. So half c bracket c by a minus y by a minus x by b is equal to half x into cross cd divided by a square plus b square. So cancel out c and half. So we get distance as distance is equal to distance as equal to root of a square plus b square and by minus ax divided by ab, or we can write it as root of a square plus b square divided by ab whole square into by minus ax, or root of 1 by b square plus 1 by a square into by minus ax. So after rearranging the terms, we can get distance as ax1 ax plus by plus c divided by root of a square plus b square. So this is a distance formula. Distance of any point P from any line x, ax plus by plus c. So next is distance between two parallel lines. Distance between two parallel lines. So suppose we have a Cartesian system and there are two lines. This line is mx plus c2 and this line is mx plus c1, and this is origin. So we have to find the perpendicular distance between two lines. So suppose we consider the first line, that is mx plus c1, and its distance is d1 from origin. So from the distance formula, distance is given by ax plus by plus c divided by root of a square plus b square. So substitute x equal to 0 and y equal to 0 in the distance equation. So we get mod of c divided by a square plus b square. So because equation of a line is mx, y equal to mx, mx1 mx plus c1, and if we compare this equation with ax plus by plus c equal to 0, then we get by is equal to minus of ax minus of c, and y is equal to minus of ab x minus of c by b. So from this, slope is equal to m is equal to minus of a by b. So distance is given by, so from here, and we know distance as we have calculated above is equal to root of a square plus b square. So take b common in denominator. We get b root of a square by b square plus 1, which is equal to, where c by b, and this is equal to m square plus 1, where c by b is equal to c1, where c by b is equal to c1. So we get the distance of first line from the origin as c1 divided by root of 1 plus m square. So this is equation A. Similarly, for second line, we get a distance as c2 by root of 1 plus m square. This is equation B. So now if you plot two lines on Cartesian system, that is, this is line L1 and this is line L, this is line N1 and this is line L2. So distance of L1 is D1 and distance of D2 is this distance is D2. So the distance between parallel lines will be D2 minus D1. So from A and B, D2 minus D1 is equal to D equal to C2 minus C1 mod of C2 minus C1 upon root of 1 plus m square, where slope equal to m equal to, so slope is equal to m of both the lines, and C1 and C2 are constant. So there is a special case when C1 is equal to C2. When C1 is equal to C2, then two lines will coincide. Then two lines will coincide. So this was about straight lines and the forms of equation of a straight line. Thank you.